You are going to investigate the relationship between volume and pressure at a constant temperature of gas. Boyle's law states that the pressure of a given quantity of gas varies inversely with its volume at constant temperature. Boyle's law was formulated by Robert Boyle in the year 1662. Here is the equation of Boyle's law. P1 V1 equals P2 V2. P1 stands for initial pressure, V1 stands for initial volume, P2 stands for final pressure, V2 stands for final volume. We need the following formula. For P1 or the initial pressure, here's the formula. For V1 or initial volume, this is the formula. For P2 or final pressure and V2 for final volume. Here are some units of pressure and volume. Here are some examples of the equivalence of units. For pressure, 1 atm is equal to 760 torr. 1 atm is equal to 101,325 Pa or Pascal. For volume, we have 1 liter equal to 1,000 ml. 1 cubic meter is equal to 1,000 liters. And 1 ml is equivalent to 1 cm cube or cc. For the first sample problem, the given are P1 is equivalent to 2 atm, P2 6 atm, V1 1.5 liters. So find V2 or the final volume. Formula: V2 equals P1 V1 over P2. Solution: copy the formula and then substitute. For P1, you write 2 atm multiplied by the V1, which is 1.5 liters, divided by P2, which is 6 atm. After that, you are going to multiply 2 and 1.5, so you get 3 liters over 6. So your final answer is 0.5 liter. As you notice in this sample problem, the value of pressure is increasing, while the value of volume is decreasing. Thus, the pressure and volume are inversely proportional. When we say inversely proportional, it has an opposite effect. For example, the amount of pressure increases while the amount of volume decreases, and vice versa. Sample problem number 2. A gas occupies 25 liters at 1.5 atm. What is the pressure if the volume becomes 15 liters? First, we are going to write the given. So we have V1 equals 25 liters, V2 15 liters, P1 equals 1.5 atm. So we are going to find P2 or the final pressure. Formula: P2 equals P1 V1 over V2. Solution: copy the formula, then substitute. So you get 1.5 atm for P1 multiplied by V1, which is 25 liters, divided by 15 liters. So we are going to cancel out the same unit, which is liter. Then multiply 1.5 and 25, so you get 37.5 atm divided by 15. So our final answer is 2.5 atm. In sample problem number 2, the amount of volume was decreased. Thus, the amount of pressure should be increased, which is 2.5 atm. So they are inversely proportional.